Welcome to the Technologies Impacting Society podcast, where we explore the profound ways that technology is shaping our world and transforming our lives. I'm your host, inaomurchu, and in this episode, I got to explore some of the societal implications of machine learning with Noah Giansiracusa. Noah is a tenured associate professor of maths and data science at Bentley University, a business school near Boston. His research interests range from algebraic geometry to machine learning to empirical legal studies. After publishing the book, How Algorithms Create and Prevent Fake News, back in July 2021, Noah has gotten more involved in public writing, speaking and policy discussions concerning data-driven algorithms and their role in our society. Artificial intelligence and machine learning are some of the hottest phrases in the tech industry right now. Innovation is focused on technological improvements with these two terms. AI being the broader concept that machines carry out various duties in an efficient manner that we humans consider intelligent. On the other hand, machine learning is an application of artificial intelligence that gives machines admission to data and makes them examine it themselves. And over time, machine learning can optimize processes and finding more efficient ways to complete tasks. Ideally, machines accomplish their goals without direct human input. This technology has the ability to transform and reinvent many industries. It's great to have you today on today's episode of Technologies Impacting Society. Do you want to go ahead and introduce yourself?
Yeah, I'm Noah Giansiracusa. I'm a math professor at Bentley University, which is just outside of Boston. And I'll get into these in the answers in a bit, but I started exploring data science and machine learning really as a teacher. I had some undergraduates who were very interested in the topic. And the more I learned it with them, the more I found it fascinating, both the pros and the cons. And I've just kind of gone deeper and deeper. But I've really veered towards trying to understand its impact on society. So I think this will be a really great conversation.
You mentioned there that you're a maths professor, but how did you segue your way completely into the area?
Yeah, so it really was a gentle segue. I was teaching really like theoretical pure math courses. So that means like theorem and proof, very like abstract stuff, which is my background, what I was trained in and what I found interesting and I still find somewhat interesting. But I just kept hearing about data science and machine learning in the news and how it's making all these breakthroughs and transforming society. And I just kept feeling like I should be more aware of that field, even if I'm not going to be working in it, and just understand what are these new waves of progress and technological development. And at the same time, the demand on the student side was just undeniable and overwhelming. So we were teaching, calculus and algebra and geometry, very traditional courses. And the students would take the courses because they're requirements, but they were so hungry for data science, for machine learning, because these are the sexy new topics, and these are where the jobs are. And the students, I think, are more economically driven, right? Like I can just teach and get my salary and tenures around the clock. And, we're comfortable in academia in the ivory tower, but the students are the ones who have to graduate into today's economy and they have to find a job. So they felt, I think, a frustration with just learning very classical geometry and algebra when they could instead be learning data science and machine learning and things that would really get them a job at Facebook and Google. But as we'll get to later in the interview, this was mixed. I did have some students where I'd go around the room and say, oh, so what are you going to do when you graduate? And one would say, I got a job, I'll be working at Facebook. And you could hear the crickets in the room because it's an oppressive job, it pays well, but it's kind of, ethically a little bit on the fence. This was a few years ago, especially. So it was hard then, and I think impossible now, to kind of avoid thinking about the ethical aspects. But it really was through teaching these students where more and more they wanted to do independent studies. They wanted to read papers and discuss them with me. Where I was teaching at the time, we had a lot of senior theses. So the students would not do original research, but explore a topic. And they really picked a lot of topics that had to do with what they were hearing about, which is this newer stuff. So I really learned it with them, and it was really fun. And I did try to do some research, but I really just kind of ended up taking, I think because I wasn't trained as a computer scientist or trained in these fields, I ended up kind of developing a bird's eye view of the subject and really kind of seeing the forest rather than the trees and kind of seeing how all the different pieces fit together rather than to be a real technical researcher. Often you have to kind of focus on some specific area and detail, really zoom in and push the frontier of research. So I kind of like stepping back and seeing the big picture. But I think, again, that came from my not being trained in the field and from working with students, because undergraduate students really want to know the whole subject. They don't need to just know a specific technical area.
So you weren't given a choice, Noah. You were pushed.
I was pushed by the students, but I went along happily and willingly. And I loved because I was learning it with them. I didn't have to be the expert. So if they asked questions that I didn't know the answer to, I could just say, it's not my area. Let's look it up and learn it together. It took all the pressure off. Versus if it's my area, then it's a lot easier to feel intimidated, like, oh, I have to get everything right. So I didn't know the answers, and that was fine.
The general public, we've often heard many inspiring stories in the area of machine learning and the breakthroughs there have been. Could you share with us a compelling use case you've encountered or worked on with your students? Yeah, and what taught you about the potential of this technology?
Yeah, so one of my first projects that I worked on, where it really was not just reading and learning, but really trying to do something new, and it was with a student, was I had a student who was majoring in math, but he wanted to go on to be a lawyer. So I thought, well, instead of just trying to do more math for math's sake, let's try to find a project that kind of weaves together math and law. And the most natural path to go down, is, I thought at the time, and I still think, is to try to look at some machine learning applied to legal data, because there's a whole rich terrain where you can try to see what machine learning can say. Law is a very old-fashioned traditional discipline, and machine learning, of course, is very modern and contemporary, and it's a very different perspective. So seeing the interface was interesting. So one of the projects that we didn't work on, but we read about that I thought was fascinating, was just trying to predict the outcome of cases, especially. So I'll give a US centric, but I'll explain the background. So in the US, the way it works is we have these various federal courts, so kind of national level courts. And if there's kind of mixed decisions or things that seem kind of questionable, these cases get appealed, which means they sort of get promoted higher and higher up the chain of courts until there's one court at the top called the Supreme Court. So a lot of countries have a Supreme Court. So the US has one, and this is, ostensibly the final word. So anything that they decide is decided. And they try not to re-decide to overturn things, but of course it happens. So the US Supreme Court, it's 9 judges. They're called justices for some reason. And they really just cast a vote. You can think of it in binary terms as a 0 or 1. It's affirm or reverse. And that really means, do they agree with, remember, they don't tend to hear new cases. They really hear cases that have already been decided by lower courts. So their affirm versus reverse vote is really, do we agree with the previous court's decision, or do we disagree and want to reverse it? So it's really just a yes or no. Do we agree or not? And that makes it much more amenable to data science, because if you're dealing with a new case, it's very hard to decide, is this really about taxation, economic policy, constitutional right? Trying to decide what a legal case is about is hard. Trying to decide what the ruling is hard, because these rulings can be hundreds of pages of written language. So what's really convenient is the judges really do cast a binary 0-1 vote, yes or no, affirm, reverse. So of course that's reductionist, it simplifies things, but that basically is what they're deciding. Do we agree with the previous court or disagree? So as I said, that it makes it more amenable to data analysis, because then you're just dealing with zeros and ones rather than 100-page text opinion. So turns out there's some fascinating investigations using data science, machine learning, and various math to explore kind of patterns in these zeros and ones, the kinds of votes that people make, the judges. So one basic machine learning application or question that people have explored is, how can you predict those votes, those zeros and ones? Let's say some big case comes up to the court. There was a famous one in the US about abortion. It was a case about whether or not they're going to overturn Roe v. Wade, for instance. So this is a huge, huge case that made, global news. And the question is, are these 9 judges, which of them are going to agree or disagree with the previous court's ruling? But you can think of this as a data problem. Based on their past votes and a whole bunch of variables about the case, whatever you can try to encode in the computer with numbers and things, which is hard, right? Cases are complex and linguistic. But whatever you can kind of translate into numbers, can you use those numbers to predict how each of these 9 judges will vote, which way the case will go? And people tried, and it was interesting. They got some success. I think the record for a while was something like they could predict maybe 65% of the time which way the case was going to go. which sounds pretty good, right? That's better than 50-50 if you randomly guessed. But it turned out, I forget which way it went, but it turned out something like 62% of cases are always affirm. Maybe it's reverse, I can't remember, but it's one of the two. So in other words, you're not just trying to beat a coin toss of 50-50. If you just always guess that the case will be affirmed, then you would be right something like 62% of the time. And using this fancy machine learning, they were right something like 65%. Is that a success or not? It's really hard to tell. And that was kind of an eye-opening experience for me, realizing that in some situations, even just getting a few percent more accurate than random guessing can be a tremendous achievement. On the other hand, it's kind of depressing to think they used all this fancy, amazing, cool topics and random forests and all this stuff you hear about in machine learning, and they only were able to nudge their accuracy rate up just a few percent from completely, the most naive possible guessing. So it made me kind of more aware of the nuance with these things, that not only is the data that you feed these very important, the questions that you're asking very important, but even your measure of success is kind of challenging and important, right? It's very hard to say, did this algorithm work or not? Did it succeed or not? Because is a couple percent improvement really groundbreaking, or is it just kind of nudging the status quo a little bit? So I found it really interesting. I didn't work on that particular one. I ended up working with this student on more of a kind of mathy geometric problem involving, it's still, I think I can kind of explain it to your audience, which is we tend to think of judges as really just voting mostly on politics. So you think of them from liberal to conservative, and maybe the liberals vote one way, the conservatives vote another way. They have these sort of alliances. But there was an interesting paper that we kind of extended that explored a second dimension. So it turns out, of course, cases are way more complicated. Human brains are not just one-dimensional. People have all kinds of complex opinions and reactions and votes. So there's some interesting math you can do to kind of explore a second dimension. It's not exactly machine learning, but it borders on machine learning of trying to understand the way that people vote by looking at more than just one dimension. So that's the area we looked at, but I really found this basic idea. I think part of also what drew me into this topic and got me really interested is this interface with this basic problem of predicting Supreme Court votes. You're taking something so complex as human reasoning, right, the human brain and the decisions we make, about unbelievably complex cases that could involve tons of testimony, tons of witness questioning, just a whole complex world filtered through a complex human decision process, and we're trying to distill it down to predicting a 0 or 1. So I think that's just marvelous in that you see how challenging some machine learning applications are, how exciting it is, the promise to probably do this, and yet how problematic it likely is that you're going to lose a lot, you're going to overlook so many details when you do try to reduce the world to zeros and ones.
As soon as you mention the word machine learning, data science, I kind of tend to switch off because all the maths involved. But a lot of people like yourself, you're excited about the future of machine learning, pros and cons with everything. I think people tend to be fascinated and they tend to dwell and focus on the potential pitfalls of technologies in general. I mean, we're seeing that with AI right now. It's big hype. Everything, the sky is going to fall on our heads. We're all going to be eaten alive by machines. In the area of machine learning, can you share with the listeners, right, a story that would show the importance or highlight the importance of balancing innovation with caution as we continue to develop these AI technologies, machine learning?
Yeah, I think what helps me is to really step back and not just think of the technology in isolation, but to really think of the socio-economic political context it's being deployed in and what it's being used for. So I do get very frustrated with this idea that AI is great, it's going to liberate us from work, we'll just be able to, sit and think, and robots will do all our jobs for us. That's the utopian view. And the dystopian is they said, oh, the robots are going to take over and enslave us or kill us all. And I just find that frustrating, because we have no idea what's going to happen. And probably it will be neither of those extremes. It'll probably be very similar to the life we live now, but we'll probably get 10 times as many emails, but we'll read and write them 10 times faster because we have more AI. Is that utopian or dystopian? I don't know. But, that's how life is. We still don't have flying cars and the Jetsons, right? Like, this is just life. It doesn't move the way we kind of predict. So I think what helps to kind of see through some of that fog of hype and fear is to stop thinking so much about AI, the technology, is it good or bad, and really just think of the uses. How are we applying this? Think of something like nuclear power. Is that good or bad? Well, it's great when it replaces carbon power plants, like coal power plants that are polluting our environment and increasing global climate change. So I think as a source of non-carbon emitting power, it's wonderful. As far as powering nuclear weapons, I think it's terrible. Maybe, some people think nuclear weapons as a form of deterrence is great. We haven't had, world war since Hiroshima. So it's hard to say, is nuclear power good or bad? It has obviously good aspects and bad. What's much better is to just isolate the applications and really think of them. What is our policy towards nuclear weapons? What is our policy towards nuclear energy as far as like power plants? What is our policy towards research towards nuclear? So we have fission, but fusion is the one that people are working on. So these are, I think, thinking of that analogy helps with AI. Don't just think of AI as our savior or killer robots. Think of how are we using it. So some examples are for automating boring tasks in the workforce. I think it'll have some mistakes, but it'll be useful, and there's probably a net benefit. For automating things like therapists and friendship, I think maybe sometimes it'll help. I think there's a lot of downsides, right? If I would feel very uncomfortable to have a teenage child growing up whose best friend is an AI chatbot rather than human, because they will develop and learn that artificial form of friendship rather than what's involved in a two-way human friendship. So I think there's a lot of risks that come from automating too much, but there's benefits that come from automating sort of harmless things. Another example is military, right? I think I'm opposed to most military things, but like if the military is going to shoot a missile, using AI to help guide it so it just hits the target and not the civilians next door, that sounds pretty good to me. Using AI to decide which people to target and when to pull the trigger entirely on its own, that sounds really scary and bad to me. So I think less thinking of what AI is and how good or bad it is, and just thinking how are we going to use this powerful technology is kind of helpful. So it's a powerful tool. It will be used, it'll be abused, and we just have to recognize that, just like many, many other things in life, right? Think of a lot of things in biology, like gene editing. Gene editing will surely help cure some diseases, and it'll probably do some really scary things too. So we just have to recognize AI is a tool. It's not kind of a life form or an entity on its own.
Just wanted to let you know that this episode was brought to you by Oriel's Magnesium Ionic Drops, called Magnesium Mineral Balance. Oriel's Ionic Magnesium Drops help you to get that deep sleep and boost your energy and immune system. I've got a 10% off discount code called INA10 that you can use at their checkout. Go to the link in the podcast description below.
The history, Noah, of machine learning, it's filled with inspiring researchers and innovators. Can you tell us a story of a figure in your field who's had a significant impact on your own work or your thinking, and why their contributions would resonate with you?
Yeah, so here I'll take an inspiring figure, but on a kind of a slightly negative, dark cloud view of machine learning, which is someone that's really kind of inspired me is Timnit Gebru, who was born in Ethiopia and went to college there, came to the US, kind of worked her way up through the system and became a very prominent figure at Google. And she was working on I forget what they called it, but basically the AI ethics team. So trying to make sure that machine learning is used for good and not for evil, let's say. And remember, Google for many years had this phrase, don't be evil. So her job was to make sure Google won't be evil. And she ended up getting fired for writing a paper with some co-authors that explains some of the risks of some of the AI technology. So what I find really inspiring is that one paper that she wrote with other authors, it's called Stochastic Parrots, and it's describing language models, so very much the kinds of things that we now have in ChatGPT, these chatbots. This was basically on similar technology under the hood a few years earlier, before we had ChatGPT. So it's kind of like the AI machine learning that powers those chatbots before we had the more consumer-facing chatbots like ChatGPT. And she and the co-authors talked about a lot of the flaws and the risks and the potential harms. And it wasn't alarmist in the sense of saying we shouldn't do this. It's saying, if you choose to go down this path and develop these are things we need to be aware of. I think that's really important, and it's level-headed. I think another analogy, I talked about nuclear-powered weapons, is something like the automobile. The car has done wonderful things for the world, and it's also done some harmful things, right? People are in accidents. A lot of cities have become less walkable. People have spread out more to suburbs. We don't use public transit like trains as much. Carbon emissions. So there's a lot of harm with cars, but very few people are saying we should abolish the car. We just try to think of how can we use this tool in a more societally beneficial way, and let's be aware of the risks and figure out how we can reduce those. So I do place Timnit's work in that context of saying, look, these language tools are useful, but here are harms, here are risks, environmental, producing dis and misinformation, a lot of things that we are now discussing extensively thanks to ChatGPT. So she and the co-authors were raising this alarm. She and one other co-author at Google got fired from Google because they were sort of pressured to try to retract the paper or take their name off it. They didn't. It was this whole saga, and now has founded a new AI institute that's much more diverse, much more kind of aware of risks. It's not just like, here's a company, let's make a ton of money. I think it might even be a nonprofit. So I find her story really inspiring because she was in tech and was trying to work within a company to make it better, and probably did a really great job for a while. When she was forced out, fired or quit or whatever happened exactly, she kept going, right? Wasn't dismayed, and started her own institute where she could do the things that she values. And she still researches, she did before and still researches now, but what it helped me realize is that it's not like there's machine learning research where you're pushing the state of the art and developing new methods and setting new records, and it's really technical, impressive. And then there's all the like ethics safety stuff that's just a bunch of like sociologists or philosophy people writing wishy-washy papers. It made me realize the ethics, the safety, the risks, all this, it's so deeply entwined in the technical research that it's all important and valuable and technical, and it really takes minds that can kind of see both, the social side as well as the mathy side, the nitty-gritty technical. So it just helped me kind of respect the safety and ethics and research side more, and to question some of the corporate behavior. It made me think, they hired her as an AI ethics researcher, and she did phenomenal AI ethics research and was fired for that. Something seems deeply wrong. For a company whose slogan was "Don't be evil," that was, to me, unquestionably evil. So that helped galvanize me to be more cynical and to not kind of say, let's step away and I don't want to think about or do machine learning. It made me kind of embrace it and say, like, I want to understand this and I want to try to help other people understand it. And I think through more collective understanding, we can reduce the chance that corporations will kind of manipulate us and take advantage of us, right? It's very easy for them to use ignorance, the fact that most people don't know about the subject, to do whatever they want. So now I'm kind of on a mission to try to educate people so we can at least recognize what's going on a little bit better, both the good and the bad.
Yeah, the ignorance is a gateway, and that was hardly ethical what Google did. It's really questionable indeed.
Exactly.
With the increasing importance of ethical AI, can you share any particular story that you might have about a situation where you yourself had to carefully consider the ethical implications of a machine learning application, and how did you navigate that challenge, Noah?
Yeah, so here I'll answer a slightly different question, because I personally, my research haven't really dealt with topics that I felt were really like I had to be on thin ice and careful with the ethics, but I've interacted and kind of entered conversations about some that I thought were very complex and subtle. So I'll give one that I've more kind of been involved in public debates on rather than I worked on in the technical sense. But I think it's interesting and kind of telling. So I got very interested in how social media companies use machine learning and AI. By the way, I keep alternating between those two terms. It's hard to kind of distinguish what's the difference between AI and machine learning. So for the listener, don't worry. It's all, basically my view is it's all just a matter of predictions. So in social media, they want to predict what posts we're going to like and click on, who we're going to be friends and follow, what products we're going to purchase. That might sound very different than a chatbot, but a chatbot is really just predicting what words it thinks I want to see as the answer to my question. So basically all of what we call AI right now is very much data-driven predictions. And that could be powering a robot. A car has to drive and predict if a pedestrian's going to cross the street at a certain time. A chatbot has to predict what words it thinks you want it to say when you ask it a question. Social media has to predict all these things. So in my mind, we're really just talking about predictions and really data-driven predictions. And whether we call that machine learning or AI, it doesn't really matter. Okay, so there's a lot of hate speech and toxic content and things on social media. And one unfortunate aspect of machine learning is it does play a role in amplifying that. It turns out really toxic negative things often get a lot of likes and comments and engagement. And because social media companies generally use machine learning to kind of maximize engagement, meaning they're going to try to make posts go viral that a lot of people are going to comment on and click like or share. Basically, they use machine learning to try to figure out what posts are going to get the most reactions from us. And that, unfortunately, often is very negative, divisive, toxic, harmful posts. So machine learning is playing a role in kind of augmenting the virality of these harmful posts. But interestingly, machine learning also plays a role in the opposite of trying to detect and remove these things. I don't know the numbers, but there must be billions of social media posts written every day. Obviously, it's far too many for humans to read and evaluate and try to filter by hand. So they really have no choice. If you're going to run a large social media platform, you have to use AI to help filter in some capacity. So they do. And I think that's a really interesting example of machine learning. The basic idea I can explain to your readers is you show whatever machine learning algorithm you're using a lot of examples of acceptable speech and a bunch of examples of hate speech. And basically from that data, if you have thousands and thousands of examples of both, it'll try to pick out patterns and learn which is which. But it's very, very subtle. There's a lot of words that if they're used within a group, especially a marginalized population, are perfectly fine and even accepted and embraced. But when they're used as an outsider towards that group, they're very demeaning and hurtful. I don't want to say examples out loud, but you can imagine there's just a lot of times a group, when there's a slur or a pejorative, really negative term that's used against a group, a lot of times that group will reclaim that word. So they will use that word to kind of take the harm and the power away. But the AI doesn't know the in-group versus out-group dynamics. It's very hard if you see, a really harmful word. Is that used by the marginalized population as a form of empowerment, or is it used by the majority population as a form of offense and suppression? So these are subtle things for an algorithm to try to pick out just by this pattern matching with words. So I think that already is a fascinating question and instance of trying to detect hate speech on social media. It's so nuanced and it's so complicated, yet it's so important and interesting. So going back to the ethical dimensions, and this actually ties back to the answer I gave to one of the first questions, which is, or a point I mentioned, which is it's very hard to know when you're succeeding or not. With these algorithms, they're never perfect, but they're never, they're sometimes terrible, but they're usually performed somewhere between terrible and amazing. And how far along in that spectrum when do you declare it a success is hard to say. So people have developed various technical ways of measuring the accuracy or performance of whatever machine learning algorithm. As I mentioned with the Supreme Court, you're trying to predict the outcome of a case, and you can see what percentage of predictions were correct. When it comes to something like predicting the outcome of an election, that's very different. You could use machine learning to predict the outcome of the big next election in your country. Your algorithm is either going to get it right or it gets it wrong. If it gets it right, was it lucky or was it smart? And if it gets it wrong, was your algorithm really flawed or was it just sort of bad luck that the roll of the dice it went the other way? So it's very hard with these situations that happen basically once to say how good your algorithm was. Again, yes, it got it right or no, it got it wrong just isn't enough for a real world where things are much more murky. But going back to hate speech, these algorithms, the AI machine learning filters are going to catch a lot of this stuff, but not all of it. So how much do you need to catch for you to say this is a victory? We've done it. Half of it, 99%, 99.999%. So it's a very human decision to decide how effective these things need to be. And there's different ways of measuring it. So to kind of circle back and finally answer your question, what I found really interesting is there was a whole debate, and this is where I kind of got involved in the commentary level, but not the technical working level. There's a whole debate about how you measure the success of these hate speech filters. Is it the percentage of hate speech that they catch and take down? It turned out for Facebook that at least a couple years ago, that percent was 5%. So 95% of hate speech, the algorithms just missed entirely. They never caught it and took it down. That sounds terrible. But what they were able to do, and I think I have to give Facebook credit, as critical as I am, they did a very good job of decreasing what's called the prevalence. And that's a technical word that in this context just means basically the percentage of all the posts you see that are something bad like hate speech. So are 1 in 1,000 of the posts you see hate speech, or 1 in 1,000,000, or 1 in a dozen? So that's the prevalence. It's how often you encounter this stuff. And Facebook has focused on that choice of metric, and they've done a good job of driving that number down. So much lower fraction of the posts you see are hate speech, even though there's still an enormous amount of hate speech on there. So it just kind of makes your mind spin. How can those two things be true at the same time? The basic answer is this stuff is out there, but you're not seeing it as much. And that's because they control the algorithm that kind of sorts what you see and not. But I just found it such an interesting, ethical, subtle debate, because a bunch of people were saying their algorithm works great. It does an awesome job of filtering out hate speech. A bunch of people was saying it's terrible. It doesn't work. And they're kind of screaming at each other, pointing out these different numbers. And what was amazing is the numbers weren't wrong. Both numbers were correct. They were just measuring two very different things. And it made me realize that's often what's happening. There's just very different ways of assessing a problem or measuring it. And it's not that we disagree in the numbers, it's that there's different ways and they suggest very different performance. So it's very subtle. And at the end of the day, it's kind of like that lies, damn lies, and statistics quote that you can paint a very different portrait depending on what your narrative is. If you want to say these tech companies are evil and doing a horrible job, you can find numbers that'll make that case. If you want to say the opposite. Another good example is there was a bunch of reports that came out about Instagram having negative impacts on teens' mental health, body image issues and self-esteem. And there it was so subtle, ethically, and complicated, because the news reported that, I'm just going to make up the numbers because I forget the details, but some high percentage of teen girls found that Instagram use was harmful and increased suicide attempts and self-esteem issues and eating disorders. And that was true, and that is absolutely terrible. But what the news often didn't say was a similar but slightly higher number of teen girls found it beneficial, and it reduced these harms because it gives people a community and they're able to talk through these things. So at the end of the day, what do you do if, again, I'll just make up the numbers, if 20 out of 100 teen girls find social media toxic and harmful and causes problems, and 25 out of 100 girls finds it's helpful and beneficial and reduces problems? It means it is doing good and bad. So it's very hard to say, should we get rid of social media? Should we block it for kids, as there's a lot of debate now? It's very hard to answer these questions because they're really ethical ones. Some people benefit, some people are harmed. It's not an all or nothing. So I think that's where we really delve into the ethical territory and leave the very strictly technical machine learning. It is good and bad. And how do we weigh the good versus the bad?
That's some insight, isn't it? Because you only hear the negative. The negative voice seems to be so loud in the press. You never hear that about the teenage girls, that they're actually getting benefit from the community aspect. That's a big part.
Yeah. And I think that's right. And that is a problem with, the way our press is set up, is that our media largely is kind of monetized or economic incentive to get reads, get clicks, get attention. And a headline that Instagram is causing teen eating disorders and suicides gets a lot more attention and clicks than one that says Instagram is beneficial. And both of those articles get more clicks and attention than an article that says Instagram is a mixed experience. Some benefit, some, some are harmed. Nobody clicks an article that's very middle of the road, both sides. That's so unfortunately our media, like traditional media, has some of the same problems as social media, that the most exciting things are kind of encouraged, and that's not always the most balanced, truthful, nuanced things. The difference I'd say is with traditional media, there's plenty of outlets and reporters and commentators that I think are very nuanced and balanced. So you can find plenty of good stuff versus social media. I think often it's harder because the algorithm kind of forces you to see whatever is popular rather than with the news. Like I mostly trust certain newspapers for the most part. They're not perfect, but they're good enough. Social media is more of a mixed bag.
Yeah, it's a hit and miss. But lastly, let's look to the future, Noah. Can you share your vision of a world where machine learning is fully integrated into our lives, and tell us a story about how this technology could bring about positive change for individuals and communities?
Yeah, so this is another great question that leads into some of the discussion with AI, thinking of it as a tool and how we're going to use it. So as one example, I think there's a really amazing breakthrough, I think it's a couple of years now, about using AI machine learning stuff to predict a very, very difficult technical problem in biology called protein folding, which I'm not an expert on the biology, but basically proteins are made up of these amino acids, and it's not enough to just know kind of what are the ingredients. It's really the function, like the biological function depends on the three-dimensional shape, the way it kind of bends and winds itself around. So it's this bizarre thing where we just don't even know the basic science of how the three-dimensional shape impacts the actual like function, what it's actually doing. So because again, it's not a matter of just breaking down to the raw ingredients as far as like reading the DNA, it's really somehow the geometry, the shape is key. So I probably didn't explain that too well because I don't understand it too well myself. But just the bottom line is there's this somehow very hard geometry problem embedded within basic biological science that we still don't really grasp. And nobody has been able to come up with a real deep theory of this. It's not like Newtonian mechanics or Einstein's equations where, someone comes along and writes the right equations like, oh, now we have a theory, we get it. We don't have that at all. But we do have lots of data. And I don't know if people have given up, but they basically accepted this is too hard to really understand conceptually. So let's just throw computers at it. And there was some amazing progress of predicting the function of these proteins based on their folding and their three-dimensional shape that kind of wins these competitions. And basically it I think, as I remember, it got to the point where human experts with a lot of, experience and knowledge could kind of work through individual examples to make these predictions, and the computer can now automate it. It can just go through a vast database of proteins and come up with the same level of prediction of functionality. In other words, I don't know if there's cases it could do that humans couldn't. Maybe there are, but it can just blast through these things so quickly that would just be prohibitively expensive for time and money for humans to do. So I might have gotten some of the details off, but the basic idea is it's opening a whole bunch of doors in biology and some things called synthetic biology, where we're going to come up with, it's not there yet, but I think we're going to come up with the next few years, a lot of interesting new medicines and antibiotics and even just core understanding of biology that we don't have now. So it's really amazing fundamental basic science that I think will benefit society and kind of move us forward, just the way 20th century physics did. There was pros and cons there, right, like with nuclear weapons, but for the most part, we understand our world in a deeper level thanks to the scientific progress. And I think that is happening in biology, and it's strongly aided by AI and machine learning. So I think that's a really interesting example where I see a future of tremendous biological progress. Like really, a lot of people say 20th century was the century of physics, where there's so many breakthroughs of understanding the world. And there's predictions, and I think they're likely that the 21st century will be that for biology rather than physics. And now I think it's becoming more and more convincing and plausible that that will be driven largely by AI helping us because biology is just so messy and complex, but there's so much data. So rather than writing a few simple equations to understand it, we have to dig deep into the data, and that's what AI is helping us do. So one piece of the answer to your question is biology. There will be amazing applications, new treatments, diseases will be cured. It won't be because we build some super smart AI robot that can just like cure cancer. It'll be because we use AI as a tool to help us develop better biological science. So think of it as assisting what we did in the 20th century with physics. It'll assist us now for biology. I think the danger is when some people act like, oh, we'll make super smart AIs that can just like cure all diseases. It doesn't work that way, but just like we have microscopes that helped us figure out things, AI will be kind of a new microscope. It'll help us dig deeper and understand better. So there in science and biology, I think we'll have sort of unquestionable progress and it'll be beneficial. As you're saying, towards the future where things are very machine learning is embedded in our lives, I think there'll be a lot of tedious things that become more automated, things that we are just so used to doing by hand that we don't really need to will be kind of faster and more automated. But I think there'll be kind of a response of people missing old-fashioned, human interaction. So I think a lot of stuff that could be automated by AI won't go away, not because it can't, but just because, like think of going to a restaurant and having a waiter serve you. I'm sure we could probably now have robots do that or a computer, but that's not the point, right? We go to a restaurant to have that little piece of human interaction. So I think in the future we'll have a more clear understanding of not what we can automate, but what we want to. What are the things where we value human experience and want to keep doing? What are the drudgeries that just no human being should do this, and let's just outsource it to a robot? I think right now the problem is we're just kind of racing to automate everything we can, especially if there's some profit incentive. But I think moving to the future, rather than a utopian or dystopian, what I see is we'll just have a better understanding of what we want to be human and what we want to give to the bots and the AI, and really where we'll make that distinction rather than going to extremes of no automation or full automation. We'll kind of figure out a nice middle ground, hopefully.
Great, Noah. Thanks for tuning in, and don't forget to subscribe to the podcast on Spotify, Apple Podcasts, or your favorite podcast platform. Together, let's uncover the transformative power of technology and its profound impact on society.